Good day, everyone. This is Jason Santos, and for today, we will start the discussion of operations research. And now we will be covering, let me pull it out here. We will cover project evaluation and review technique, or what we call as Pert. Okay, so this is already the third topic under operations research. So let's get started. So just to introduce the concept of PERT, any project involves planning, scheduling, and controlling a number of interrelated activities with the use of limited resources, namely men, machines, material, money, and time. This project may be extremely large and complex, such as the construction of a house, a highway, a shopping center, complex, etc. Thus, with the introduction of the new products and research and development and projects, uh, PERT is needed in order to make sure that the project follows a certain schedule, and we are meeting the schedule, the target schedule. Now, it is also required that the managers must have a dynamic planning and scheduling system to produce the best possible result and also to react immediately to the changing conditions and make necessary changes in the plan and the schedule. So, a convenient analytical and visual technique of PERT and CPM proved extremely valuable in assisting the managers in managing the project. So, PERT stands for Project Evaluation and Review Technique, developed during the 1950s. So, the technique was developed and used in conjunction with the planning and designing of the Polaris missile project. So, that was the origin of the PERT. CPM, on the other hand, is another method which stands for Critical Path Method, which was also developed by DuPont Company and applied first to the construction projects in the chemical industry. Though both PERT and CPM techniques have similarity in terms of concepts, the basic difference is that PERT is used for analysis of the project scheduling problems, while CPM has a single time estimate and PERT has three time estimates for activities and uses probability theory to find the chance of reaching the scheduled time. So project management generally consists of three phases. So we have planning. Planning involves setting the objectives of the project, identifying various activities to be performed and determining the requirement of resources such as men, material, machines, etc. And then the cost and time for all activities are estimated and a network diagram is developed showing sequential interrelationships, predecessors, and successors between various activities during the planning stage. The second phase is the scheduling, and based on the time estimates, the start and finish times for each activity are worked out by applying forward and backward pass techniques. Critical path is identified along with the slack and float for the non-critical parts. And then the third phase is controlling. So controlling refers to analyzing and evaluating the actual progress against the plan. Reallocation of resources, crashing, and review of a project with periodical reports are then carried out. So now we go to the components of a PERT or a CPM network. So PERT and CPM networks contain two major components. These are the activities and events. An activity represents an action and consumption of resources such as time, money, energy required to complete a portion of a project. Activity is presented by an arrow. So this is the activity and it is referred to as letter A. Okay. It could be any letter, but it always starts with letter A because that's the first letter in the alphabet. And to avoid confusion, we start with the first letter. This also applies to the numbers. We follow strictly the numerical order, and we always start with 1. Okay, and then this is the activity, and you call it activity A. You have a definite start and ending. And then an event or node will always occur at the beginning and end of an activity. The event has no resources and is represented by a circle. Thus, what we see here. The event and J event, or the I event and J event, are the tail events and head event respectively. So this one represented by letter I, or normally it's 1 and then 2 if we will use the numerical order. This is the tail event, meaning the first or the starting point, and then head event is where the direction of the event goes to, okay, or the end of the event, the tail of the event, okay. So that collectively is called an event. And then the activity here is represented by this letter A. So activity A, and this is the event. And then we have merge and burst events, which refers to one or more activities that can start and end simultaneously at an event. These are represented by figures 8.3 A and B, such as what we are seeing here. These are merge events, meaning all of the lines or nodes are pointing towards one letter or one number, one direction. And then when you say burst events, there is one letter or number, and then multiple events are coming out of that letter or number. So here, as you can see in the image, these are the differences in the directions of the events, whether this is a merge or a burst event. Now, preceding and succeeding activities performed before given events are known as preceding events. Okay? And then activities performed after a given event is known as succeeding activities. So from the terms itself, preceding and succeeding, these are both self-explanatory. So for example here, we can see that activities A and B precede, meaning they occur before activities C and D. It is shown by the directions, the directional arrows, and by the drawing or the diagram itself. Okay, you cannot go to activity C or activity D without finishing first activities A and activities B. So they precede, and these are the succeeding events. A dummy activity is represented by an imaginary line or an imaginary activity which does not consume any resources and time, and it is called a dummy activity. Dummy activities are simply used to represent a connection between events. Because we always wanted to make our diagrams interconnected, we have to make a certain dummy event or dummy activity. Um, to maintain the logic in the network, to maintain the interconnection within the network. It is represented by a dotted line in a network, such as this one. Okay, so the given only shows um, activity A, B, and C, and these are the events. However, if we wanted to make sure that this is an interconnected activity, we don't want to leave both of these circles blank. Thus, we will create a dummy activity with a dotted line or an imaginary activity. Now, let us take note of the errors that we need to avoid in constructing a network. Okay, first, two activities starting from a tail event must not have a same end event. These burst activities, just like this one, starting from 1 and then going to 2, cannot end in the same manner. Okay? To ensure this, it is absolutely necessary to introduce a dummy activity, just like this one. What we did is that we created this dummy activity so that both of these do not end in number 2. But there must be another point where this would go to. Okay? Next, we have the looping error. Looping error should not be formed in a network as it represents performance of activities repeatedly or in a cyclic manner. Just like this one. This is incorrect because after the events, or let's say this is event A, going from 1 to 2, this line is already incorrect because 3 cannot go back to 1. Okay? It could lead to another direction, but definitely it could not lead to a preceding event or a prior event. It must always go to a succeeding event. C. In a network, there should be only one start event and one ending event as shown below in figure 8.8. So this is pretty self-explanatory. This is similar to instruction in A. Thus, we have to create a dummy activity. D. The direction of arrows should flow from left to right, avoiding mixing of directions. This is an emphasis of instruction here in B, okay, or the loop error. The direction of the arrows should always go from left to right, okay? They cannot go from right to left or the opposite. And then rules in constructing a network, there's no single activity that can be represented more than once in a network. So meaning there should be no repetition of the activity. Uh, in a business sense, we also are trying to avoid any repetitions in activities. The event numbered 1 is the start. Okay, it is the alpha, the genesis of any activity. And an event with the highest number is the end event or the last, the omega or the ending. Before an activity can be undertaken, all activities preceding it must be completed. That is, the activities must follow a logical sequence or interrelationship between activities. In assigning numbers to events, there should not be any duplication of events numbered in a network. Dummy activities must be used only if it is necessary to reduce the complexity of a network. And then finally, a network should have only one start and one end event. So here is our example. Okay. This table is already a given. So in your future activities and examples, you need not to worry because this will already be pre-plotted for you. Okay. And on the first column, we will see the name of the activities. Second column shows the start and finish of the event. Third is the description of the activity. Fourth column is the predecessor or the origin. And then fifth column is the time and duration of days. So first, our activity A starts from 1 and ends with 2. And this activity is described as the preparation of the house plan. It has no predecessor because again, number 1 is the starting point. It has not originated anywhere because this is the beginning. Time and duration of days is 4. So let's look at that in our network diagram. So here we can see 1 going to 2, and the name of the activity is A, and the time and duration is 4 days. And the description is preparing the house plan. So this is your first row practically. Preparing the house plan, events 1 to 2, activity A, time duration is 4 days. Next, activity B. Description is construction of the house. Starting and finishing of the event is 2 going to 3. The time is 58 days. So again, clearly every information on our table is depicted in the network diagram. Now here is the part, I shouldn't say confusing, but rather you should take note of this. Number 3 is the starting point for multiple events. Thus, this is what we call a burst event. Okay, so here we can see that letter C, activity C, starts with number 3 going to 4, and this is fixing the door and windows. Its predecessor is B, meaning it has to start here from B. And then time duration is 2 days. Next, we have D, which originates as well with 3 or predecessor B. So it also came from here. This is wiring the house, and the time duration is 2 days. So see, from number 3 or the end of activity B has started the burst event, which burst into 2 simultaneous events. And then E is starting at 4, ends with 6. This is event E, painting the house. Time is 1 day. And then activity F starts with 5, this one, or predecessor D, because this is D, which refers to polishing the doors, and ends with 6. Okay. So this is how you will make your own network diagram. Now here's what we need to do, and I will give this to you as an assignment. You have to construct your own Pert diagram for this example table problem. So there you have it. I hope you have learned the discussion. And for more videos like this, just check out my playlist, particularly in operations research. If you have questions, feel free to send me a message on all the channels and platforms I am in. Thank you so much. Stay safe and God bless everyone.